step 4.2 and actually find the other solutions for y. So basically now we have to apply this cube root of unity solutions to our cube root of the z. So if we take this one right here, so what I'll do is I'll copy this just for later, so it saves time from writing. So copy that, and I won't use that right now, but what I'll say is, so let's say we had our first number right here. So we had a cube root of our z cubed, and then this was the cube root of a big number. This equals to cube root of a big number, and that's the same thing as writing, well, cube root of the big number, and then times it by cube root of unity. Cube root of 1 there. And in other words, this gives you the 3 solutions. So again, this is 3 solutions. And what ends up happening is we have this cube root of 1. So this equals to cube root of that big number times it by the first solution, W0, which is just 1. That's just a principal. It's going to be called the principal root, so the W equals 1, like that. And and I'll just put it as this equals to just a cube root of the big number, just by itself. Now the next one is, that's one solution. The next one is going to be equals to the cube root of 3 times by the second solution, W1. And the next one is going to be, so these are all equal to this, because you have 3 different solutions. Times it by the third cube root solution of unity. Alright, so now let's put this together, and I'm going to paste our solution earlier, or from before. So I'll paste this right here. So this is what we had. And this is what we had as the first solution. It doesn't matter if you picked a plus or minus. So I'll call that, and I'll call this equals to z1. And then from z1, we were able to solve for y1. And there's y1 right there. Remember what we did? We just plugged that in. So plug into our Viet solution. I think it was, what was that called again? A Vita solution. Anyways. So y equals z minus p divided by 3z, and so and we put in z1. We put this one right here inside there. So now we're gonna have to find z2 and z3 and so on. Yeah. So this is the first z1. So what I'll do now is I'm gonna call z2 equals to just this principal solution times it by w1. So this one right here, and I'll say that this solution is going to be called z1. This is z2, and this is going to be z3, like that. So z2 is just going to be equal to z, which is right there, z1, equals to z1 times w1, and then I'll put a bracket right here. So, and also z3 is going to equal to z1 times the second one, w2 right there. And now note that we know that now we've plugged this all inside, or inside the y solution. So now what we end up having is y. I'll put a bracket like this. So we have this. Oh, actually, I'll leave that right now. Not a bracket, line. But anyways, so now we're going to put the second solution. So y2, remember this equals the Viet solution. So z2 minus p over 3z2, and there's a w there. Well, actually, no, that's afterwards. This is just z2. So now this equals to z1 times by w1. This is the first one there. Then minus p times by 3 z1 w1. And we also know that we solved earlier that w1 over where is that number right here? Yeah, this right here. So we also note that 1 over w1 is equal to w2. So now, in other words, in our case, we have the z1 w1 now divided by, this is a 1 over w1. So this equals 2. This becomes w2. So this becomes z1, or put the w's in front. So w1 z1 minus, and then this is going to be w2p over, or actually I'll put the w2 in front. So w2, and then this is going to be p over 3z1. All right, so we got this. Now basically what this means is we just take our solution for w1, for y1, then we add the w1 and 2 there. So we'll take this right here. All right, so there's our w1. So now what we're going to do is we're going to shift this over We're going to shift this over as furthest as we can. Yeah, so that's a good spot there. And now this is going to be W2. So then W2 is going to be, put a W2 in front of this one. And what is W2? Because this is just a Z1. This is a Z1 becomes now the negative conjugate of Z1. And then the bracket for, and I'll put the complex number. And so W2 is -1, and then -1 over 2 minus I squared 3 over 2. So this is going to be, I'll put this all up from or backwards. Over 2 minus -1 over 2. Like that. So that's our W2. Yeah, alright. So we got that. Now I'm gonna just shift this over. So yeah, it saves a lot of time from actually having to type it all over again. So move this over here and put this bracket, and I'll erase this one. And I'll put, now it's going to be the I squared 3 over 2 plus, going to have to fit all of this in. This is 2, and then this is going to be -1 over 2. And that's our W1. And this is going to be now our Y2. So there it is. There's a solution. All right. And now we have that. And similarly, I'll do it for completeness. Yeah, similarly, we're gonna, and I just fix the spelling right there. There's no extra I in the middle of R and L. Anyways, similarly, we have Y3. This equals to Z3 minus P over 3Z3, and I just put it for completeness. This equals to Z1. Now we're gonna multiply by W2, and then minus, and then it's gonna be P over 3Z, Z1, W2, and then 1 over, so 1 over W1 is W2, so flip that around, this becomes the W1, so this just equals to, put that in front, W2, Z1 minus, and then we're going to get this multiplied by W1, so flip that over, P over 3Z1. So in other words, it's the exact same thing, but now we flip this one and this one. This becomes W, this is W2, this is W1, this becomes W2, this becomes W1. So we can literally take this entire thing, so copy this, and then multiply, paste it. So we get this whole thing, like this, and now what we do is, this becomes a positive. That's our W1. Now this becomes a negative. This becomes W2. So that's all it is. That's W2 and that's W3. Oh yeah, and then we erase this like that.